So I hope you can relate antenna with your circuits. Now I'm going to plot the return loss. So we have seen that the design frequency is 1.74 G, right? So at 1.74 G, the return loss should be less. So you can see here the return loss is actually the return loss is a measure of effectiveness of power delivery from the transmission line to the antenna. So return loss is the power sent towards the antenna and the power reflected back. It is a positive quantity for passive device. Actually, antenna is a passive device, right? So actually return loss is here you get 7.5 dB. It is actually taken as minus 7.5. It is a loss. So loss is 7.5. Okay, loss is 7.5. 7.5 dB is lost. Remaining thing is transmitted towards the antenna. Active devices will have negative return loss. Or I can say active devices will have gain, whereas passive devices will have positive return loss. So return loss is close to 7.5 dB. Okay. So now reflection coefficient. So what is the reflection coefficient of my antenna? See, remember antenna is a passive device. Correct? Just you need to excite the RF signal to your antenna, and antenna starts radiating your signal. But all your diode, transistor, FET, CMOS, everything is active devices because without VCC or VDD or forward bias or reverse bias, these components will not work. Okay. And S11 you see at the design frequency, the reflection coefficient will be very, very minimum. So you can see S11 is close to minus 7.5 dB, so which indicates that this antenna is very good at resonating on 1.74 gigahertz. Okay, and you know when your resonant frequency, when your reflection loss is minimum, your VSWR should be minimum. At 1.74, you see VSWR. Ideal value of VSWR is 1. VSWR is 1 is ideal value, but here you see VSWR is close to 2. And why it is close to 2.2 or something? Because my impedance is not 50 ohms. If you change the impedance of the antenna to 50 ohms, if you change the impedance of the antenna to 50 ohms, then you will get all the standard values. Say VSWR will be 1, reflection loss will be even more smaller. It will become, the return loss will go up. So all these parameters will change depending on the impedance. Now we are going to plot the bandwidth. And you know, all antennas are single frequency devices, so they have a very narrow bandwidth. See here how the bandwidth is narrow. The bandwidth can plot using S11. Any bandwidth you find, it is going to be same. So you just need to find the minimum point, mark the 3 dB line. So I think assume minus 30 is your thing, minus 30, minus of minus 3. So minus 30 plus 3 is minus 27, mark minus 27, you have 2 points. Find F upper cutoff frequency, lower cutoff frequency, subtract them, you'll get the answer for bandwidth. Okay, so the bandwidth is very, very narrow. So instead of 20, currently the impedance is close to 20, right? Ideally, the impedance has to be close to 50. So we have to change the impedance and see. So here you see, they're giving 20, now I'll give 50. I'm changing the value to 50, see what is happening. Now you see how the bandwidth is becoming changed.